Recall that when a function has a function inverse, the function and the inverse of that function represent the same relationship, but the input and output quantities are switched. So as an example, suppose y is a function of x, so that y equals f of x. So in this case, the name of our function is f. Let's also assume that x is a function of y. So we know that f of x equals y, and since x is also a function of y, this function f has an inverse. And so we have a function inverse, f inverse. And the f inverse takes something as its input and then outputs something else. So with inverse functions, the input of f inverse is the output of f. So y becomes the input to f inverse, and then the output of f inverse is the input of f. So we switch these inputs and outputs, and so we say f inverse of y will give us the value of x. So we have the same relationship, we're just switching inputs and outputs. And therefore, we could say that x is equal to f inverse of y. Let's look at an example of function inverse in an applied context. Suppose a rocket is launched into the air. We'll let t represent the number of seconds since the rocket was launched, and we'll let h represent the rocket's height above the ground in miles. So we can assume that h is a function of t, and we'll go ahead and name this function g. So we could say that the height h is a function of t, and we'll name that function g. So we know that h equals g of t, and if we wrote something like g of 2.3 equals 1.5, if we were to write a statement like this, then we can make sense of what this means. The input to g, this 2.3, is a value of t, so that's a value of t, which is a number of seconds. And then the output of g is a value of h, which tells us that when 2.3 seconds have elapsed since the rocket was launched, the height of the rocket above the ground is 1.5 miles. Let's also assume that t is a function of h, or the time since the rocket was launched is a function of the rocket's height. So if t is a function of h, that means this function g has a function inverse. So we have this function inverse g. We need to think about what the input of g inverse is and what the output is. So recall that the input to g inverse is going to be the output of g. So the input to g inverse is a height above the ground in miles, and then the output of g inverse is the input to g. So in this case, g inverse of h equals t, or this function g inverse takes h as an input and then outputs the value of t. So knowing this, we can make sense of expressions involving this function g inverse. So let's suppose we have an expression like g inverse of 2.3. Let's think about what this expression represents. Recall that the input to g inverse is a value of h, or a height above the ground in miles. So this number right here, 2.3, that's a value of h, meaning that the rocket is 2.3 miles above the ground. And then the output of this expression, or the value of this expression, is a value of t. So this gives us a value of t. So g inverse of 2.3 gives us the value of t when h equals 2.3, or the number of seconds that have elapsed since the rocket was launched when the rocket is 2.3 miles above the ground.